Hello AP Physics 1, it's Mr. Ng, and I have a short lesson for you on torque. So what is torque? Torque has the symbol little t, all right, that's torque, and torque is rotational force, right? You know how like alpha is rotational acceleration, torque is rotational force. And the easiest equation for torque is force, the perpendicular force times r, right, times the radius. Meaning the larger the radius, the farther away you are from that angle of rotation, the more force you have, the more torque you have. Meaning here we have a little fist and it's putting out a force, and the farther back, the larger this r is, the more torque is applied. So really, you could apply the same amount of force, but have a really long lever and have a lot of torque, which is good for me because I'm a little guy. And sometimes I gotta change my tire, so I buy one of those really big, big crosses to kind of take the bolts off. Like if I didn't have one of those ones, I would have to stomp on this little guy nonstop. Like I need that leverage to take the tires off of my car, right? That's torque. Later on, you're gonna have other equations. What if the force is not particularly perpendicular? What if you're not so lucky? What if the force is a little bit wonky like this? Then our equation for torque goes like this. It's going to be sine theta force times r, right? We're basically just trying to get to that perpendicular force. Or even later, it's not so relevant today, you're going to learn that torque is equal to the moment of inertia times alpha. That's why we spend so much time talking about the moment of inertia. We're going to be talking about it quite a bit. But for today, let's go through some easier stuff, just force times r, right? There's one more thing that you got to know for this lesson, and that's about signs. So here, with torque, if it's all clockwise, right, going with the arrows, then this is all negative actually. And if it's all counterclockwise, then these guys are positive, all right? So just think on the right-hand side, up is positive, down is negative. But if you flip it to the left-hand side, then down is positive, up is negative. And I don't know if that's the best way. Counterclockwise, positive, clockwise, negative. Stick with that. Let's start with a very easy example about torque, biceps torque. The biceps muscle exerts a vertical force on the lower arm, bent as shown in the figure. For each case, calculate the torque of the axis of rotation to the elbow, assuming 5 centimeters from the elbow. So let's start with our equation. Torque is equal to the radius times the force that's perpendicular to it. So we have our radius. It's really tiny. It's 5 centimeters, which is equal to 0.05 meters, times our force, which is 700 newtons. We got lucky, it's already perpendicular. So what we gotta do is multiply across. That means the torque is equal to, it's 0.05 times 700. I got 35 meter newtons, or newton meters, however you want to do it. It means the same thing. And if you're clever enough, you might notice that this is the same unit as work. It is the same unit as work. We'll talk about that when we talk about energy. Let's do part B of that exercise, where it wants you to compare these two forces. It wants you to compare FB versus FA. This is at 20 newtons, and this is at 30 newtons. And if you notice, the tricky part about this problem is that we don't have a perpendicular force on FA, right? FA is at 30. So let's do that tricky one first. FA is supposed to be R times the force that's perpendicular. So we got to figure out what that perpendicular force is. So here we know the hypotenuse is 30 newtons. So we want this guy. We want the force along the y. And if this theta is 30 degrees, let's remember our sine cosine, right? Along the x, this is cosine theta. Along the y, this is sine theta. F times sine theta, F times cosine theta, right? So almost always, it's just sine theta to go up and down, right? The force, the hypotenuse times sine theta to go up and down, and then the hypotenuse times cosine theta to go left and right, all right? That's if the angles right there. You can figure it out at each one. So here, we're going to do sine theta, right? So FA is equal to our R. Our R is going to be 1 meter times F, which is 30 newtons, times sine theta. The theta is going to be 30. You punch that thing into the calculator, you're going to find that F of A is equal to 15 Newton meters. Done. Let's do F of B. F of B is a lot easier, right? It's just R times the force that's perpendicular. In this case, R is equal to half a meter. And then the force perpendicular is already given to us. It's 20 newtons. So F of B is equal to 10 newtons. There you go. FA is a lot larger, even though it's not perpendicular. Even though it's at an angle, it's supposed to be weaker. That radius, that distance away, really adds to that force. So F of A is greater than F of B. Done. Let's do our last example. This last example just adds in one more new idea. That's just about positive and negative in a rotating object. And again, if it's counterclockwise, right? If it's going counterclockwise, that's positive. If it's clockwise, it's negative, right? Again, counterclockwise is positive, clockwise is negative. So, two thin disk shaped wheels of radii RA is at 30. So this is 30 centimeters, right? And then RB is 50 centimeters. This thing is 50 centimeters. I'm just going to change that to meters right now. This is going to be 0.3 meters. This is going to be 0.5 meters, right? Done. Are attached to each other on an axis that passes the center of each. Calculate the net torque of this wheel due to the two forces. Ooh. Okay, so we have two forces, right? The net force is equal to F of A plus F of B. Let's go through with each one of them one at a time. Let's do F of A. F of A is down here, right? That's pretty easy because look, it's 90 degrees to the rotating axis. So F of A is equal to R times the force that's perpendicular. We know that R to be, look, it's in the middle, so that's going to be 0.3 meters times the force is 50 newtons. Okay, so this is 0.3 times 50. That's 15 newton meters. That's the F of A. And look, it's going down on that side. It's going counterclockwise, so this is positive. Good. Let's do FB. FB, we have to do some sine cosine stuff. So we actually want this force, this up and down force. Oh wait, no we don't. I don't want that arrow, silly arrow. Instead, we want this arrow, right? We want that to be against, tangential to that wheel. So if you look at it, that's cosine, isn't it? It's cosine theta. This is F cosine theta. Okay, so this is R times the force that's perpendicular to it. In this case, it's going to be, the R is 50.5 meters. And the force that's perpendicular to it is going to be 50 newtons times cosine theta. Cosine of 30. Okay, again, for those of us who aren't so familiar with it, if this is our theta, this is going to be sine theta, this is going to be cosine theta, right? And that's what we want. We want the one that's going kind of left and right there. So F of B is equal to, let's see, 0.5 times 50 times cosine 30, and I get 21.7 meter newtons. But wait, think about the sign. It's going clockwise, so it has to be negative. So our sum of forces is equal to 15 meter newtons minus 21.7 meter newtons. So our sum of forces is equal to negative 6.7 meter newtons. Biggest takeaway is you have to be aware of clockwise and counterclockwise. To sum up, our go-to equation for this entire lesson is torque is equal to radius times the force that's perpendicular. But sometimes that force that's perpendicular, it's kind of hard to find. So we're going to have to do our sine cosine stuff, meaning if we have theta, sometimes we'll have to do the force along the y. All right, this is our regular force, which is equal to F sine theta. We used that once. Sometimes we need to use our force along the x. This is equal to force cosine theta. All right, so sometimes our force perpendicular, we need to use either the sine or cosine component. And then on top of that, don't forget that if it's going clockwise, it's negative. And if it's going counterclockwise, it's positive. Thank you very much for watching.